Welcome! Can the sun produce a superflare? Now, the answer I would have given about a month ago is somewhat different than I'm going to give today in the light of some new research. How do you know if you've seen an important flare? Well, flare intensities are measured by their X-ray flux. And the smallest size significant flare is a C flare marked here on the right. The next size up is called M, and the next size up is called X. And don't ask me why they use those particular letters. I haven't got the foggiest idea. So basically, an X1 flare is equivalent to 10 times an M1 flare is equivalent to 100 times a C1 flare. And you can see the y-axis here is a logarithmic axis. The flare shown here on the 2nd of April 2001 was one of the largest flares we've ever seen, and that was an X20 flare. Well, can you get flares that are even larger than X20? Well, yes, we've had one. On the 4th of November 2003, we had a flare that was estimated to be X28. It may have been larger, but some of the detectors saturated. But some stars can produce flares that are much larger than the sun. They dwarf the solar flares by orders of magnitude. But why the difference? What's different about those stars from our sun? There was an event that was allegedly much larger than the X28 flare, and that was the so-called Carrington event in 1859 on the 1st of September. Carrington observed a couple of brightenings in a large sunspot group. Remember, they didn't have X-ray observations back then. And he saw the brightening in a sunspot region. This was the first ever observed white light flares. White light flares only occur when there's extreme flares occurring on. Either it gets hot enough and bright enough that it makes the photosphere glow. A little while later, this event was followed by a spectacular auroral display and a huge geomagnetic storm. And these effects actually were not just limited to high latitudes as most geomagnetic storms are. This, in some cases, stretched all the way down to Havana, Cuba. So this was a very big event. As I said, other sunlight stars produce superflares. They can be 10 to 1,000 times the size of any solar flare. 365 of these flares have been observed on sunlight stars. However, 75% of them were on younger and faster rotating stars. The younger the star and the faster it's rotating, the more it can wind up its magnetic fields and store magnetic energy to produce these large flares. So that's one difference. However, that still leaves about a quarter of those flares on slow rotating stars like the sun. So are these remaining stars that produce superflares very different from our sun? Well, it seems they are. It seems that they produce huge area sunspots, unlike the sun. Here's an artist's impression of what one of those regions would look like. Basically a spot that covers most of the star. So these much larger and stronger fields are capable of storing more magnetic energy than the sunspots are, so they can produce much larger flares. So we can draw a conclusion from all of this. The sun is no longer a fast rotator, nor does it produce huge sunspot groups that cover most of the sun. So the sun cannot produce these super events. However, we have to take some new research into account. The University of Lund has been doing some research into isotope distribution in ice cores. When the sun produces a major flare, it produces what's called solar energetic particles. These are relativistic particles that come to the Earth in just a few minutes. They irradiate the top part of this Earth's atmosphere, producing these exotic isotopes. And they found traces of a very large deposit of these isotopes 9,125 years ago, both in the data from Antarctica and also from Greenland. So this was a global event. And I've shown on the right here the results of their analysis. And you can see there's distinct peaks all at exactly the same time in all these different locations and in different isotopes. So these were formed when solar energetic particles impact the upper atmosphere of the Earth. This implies an event of 100 times larger than any flare we've seen to date. So this is a super flare. What would be the effect of one of these events were to occur now? Well, the most dire effect would be that it would strip away our ozone layer, leaving us vulnerable to incoming ultraviolet light It causes things like skin cancer, and not just us, all plants and animals as well. It would destroy a lot of our space assets, communication satellites, weather forecasting satellites, and military surveillance satellites. It would destroy most of the ground-based sensitive electronics. It would be effectively an EMP. Any astronauts in deep space or on the moon or Mars would be killed by radiation poisoning. It would destroy most of our power grid system, at least at moderate to high latitudes. It would take us decades to recover both technologically and financially. So to answer our original question, yes, these events can occur on the Sun, it seems. However, they seem to be very unlikely or very rare. But the question I do have is, was this event from the Sun? One of the things that came out of their research was this happened near solar minimum, when solar activity was low. So could this have been something else, like a nearby nova or supernova? But there's no evidence of either of those happening either. So I am confused as to what might have caused this if it wasn't the Sun. So thank you for listening, and stay safe until next time. Goodbye.